Hello and welcome to our webinar on short multiplication in Key Stage 2. When is short multiplication introduced? In Year 4, children progress from multiplying using informal written methods such as repeated addition to the formal written method. By the end of Year 5, children should be able to confidently multiply up to 4 digits by a 1-digit number in preparation for Year 6. So how is short multiplication first introduced? In Year 4, the short multiplication method is introduced for the first time, initially in the expanded form, as seen below on the left, and then in the formal short single line form, as displayed on the right. Children first do calculations where there are no exchanges, then move on to one or more exchange. Place value counters may also be used to illustrate the structure of short multiplication by presenting the concrete or pictorial model alongside the abstract formal written method. This is particularly helpful in aiding children's understanding of exchanging. So first of all, we're going to look at the expanded form. So if we take the calculation 21 multiplied by 4, we can represent it visually first using place value counters. Here we can clearly see that 21 multiplied by 4 is the same as 4 lots of 21. Alongside this, we can also introduce children to the expanded written method. Here you can see our digits have been organised using our place value headings. The larger value is on top, with the 4 underneath in the ones column to represent it has the same value as the 1. However, children should be reminded at this stage that multiplication is commutative, which means if we swap the numbers around, the product or answer will remain the same. Children should also make sure they are placing 1 digit per square. This minimises chance of error in calculation. We always start with the lowest value digit. 1 or 1 multiplied by 4 equals 4. Then 2 tens or 20 multiplied by 4 is 80. Children should know that 2 times 4 equals 8, therefore 20 multiplied by 4 is 80. At this stage, it is important that children understand the value of each digit, which is why it is helpful to write the actual calculations in brackets. Finally, we add our answers together. 4 plus 0 is 4, and then 8 add nothing would be 8, giving a final product of 84. Once we are confident that children understand what is happening when we multiply by a single digit, we can move on to the more efficient single line form. Here we have 24 multiplied by 4, which again can be represented visually using our place value counters. Again, we can set out our digits using our place value headings, but this time we only have a single line for our answer. Starting with our lowest value column first, 4 multiplied by 4 is 16. However, we now need to exchange 10 ones for 1 10, and we put this underneath our tens column and the 6 in our ones. This exchange is also demonstrated visually using the place value counters. Next, we multiply 2 by 4 to get 8, add on our 1 or 10 to make 9. This gives a final answer of 96. At this stage, it is still useful to remind children that whilst we may say 2 multiplied by 4 is 8, the actual calculation is 20 multiplied by 4, which equals 80. We are then adding on the 10 to make 90. A further example is 61 multiplied by 3. Again, we have our visual representation alongside our formal method. Starting with our lowest value column, 1 times 3 equals 3. Then 6 times 3 equals 18. In this example, we now need to exchange 10 tens for 100. However, as we have no more digits to multiply, our 100 goes straight into our answer box, giving a final product of 183. As children become more confident with this method, the number of digits continue to increase. Here we have 251 times 3. The only difference is that we have added an extra place value column for our hundreds. 1 multiplied by 3 is 3. 5 multiplied by 3 is 15, exchanging 10 tens for 100. 2 times 3 equals 6. Add on our 1 to make 7 or 700. As with a lot of maths, if children understand the mathematics behind the method, they are able to multiply by any number of digits as they continue to move up the school. This is why using concrete and pictorial representations is so important at the beginning of this journey. Before we go, a few common misconceptions to be aware of. If we look at the examples below, as you can see, the calculation has been set out correctly. In the first example, 6 times 4 is indeed 24, but rather than exchanging underneath, they have put the 2 straight into the answer box before doing 4 times 2, which is 8, giving an incorrect answer. This has been corrected on the right, so 6 times 4 is 24, but they have correctly exchanged 21s for 2 10s underneath their answer. Then 2 times 4 is 8, add on the 2 equals 10, giving a final answer of 104. Another common error is also displayed adjacent. So if we look at the first example, 4 times 7 is 28. However, in this case, they've forgotten to exchange their 1s for 10s before multiplying 7 by 7. Again, this is corrected on the right with 21s exchanged correctly for 2 10s underneath. The final and possibly most common error is forgetting to add numbers exchanged. This is why it is useful for children to cross out as they are adding. Thank you for listening to this webinar, and we hope you found it helpful.